All right, so we're going to get started looking here at example 3. And looking at it, finding the exact values of the remaining trig functions. So this is kind of a comprehensive question that will be on your quiz, so it's good to kind of get practice with this process. And kind of the 3 things that you guys really need to have down, have memorized. If you need index cards to write down and test yourself, we can get them to you. But you guys have to have the unit circle memorized. You guys have to have this memorized where everything's positive and negative. And then you have to have these 6 ratios memorized. Sine, cosine, their sister functions, and then tangent and cotangent. If you guys don't have those things memorized, it's going to be a real rough quiz for you. So getting started, looking at the ratio of sine, what do we know sine as? What's the ratio? Y over R, perfect. And then the second piece of information that we get from this question says we're in quadrant 3. And so quadrant 3, if we're using, does anyone remember the kind of device we were using to tell us where everything's positive and negative on our unit circle? It was like the 4 words of saying.
Smart trig class.
Yep, smart trig class, perfect.
I know.
A smart trig class. So that tells us in quadrant 3, a smart trig. T for trig, that tells us that tangent is going to be positive. It also tells us that, what's tangent's sister function? Cotangent, yep, it tells us cotangent is also going to be positive. And then the other 4 are going to be negative there in quadrant 3. So then moving on, we have sine equals negative 5 over 13. So that tells us that our y value is going to be negative 5. And we can write that as 5. And then our r value is going to be 13. So what's the theorem that we use with right triangles to, how are we going to figure out our x side length? Yeah, what's that called? What's the fancy? Pythagorean theorem, perfect. And like you guys were saying, it's r squared equals x squared plus y squared. And we already have y and r, so we're just going to straight substitute it in. And is anyone good with their perfect squares? Does anyone know what? Oh, yeah. Yep, so the best way we think to kind of figure out what's negative and positive, right? Because this is negative 5 for y. It's just to write these values as all positive. So write your x, your y, and your r is all positive. And then at the end, you'll have your ratios, and they're all going to be positive because all of these, the x, y, and r are positive. And that's why you have to remember you're a smart trig class, because then you can go through at the end and make the ones that need to be negative, negative. Does that make sense? Another question, or are we good? All right, cool. So straight substituting, anyone good with your perfect squares? Anyone know what 13 squared is going to be?
169.
169, good. First period, maybe they were still a little asleep. They struggled with that one. And then x squared, we don't have x. We're solving for x. And then y squared is going to be 5 squared, which is 25, perfect. And then from there, we're going to subtract 25 from both sides. Do a little bit of subtraction. 9 times 5 is 4. There's 9 minus 5 is 4. 6 minus 2 is 4. 1 minus 0, 4. So then 144 equals x squared. Anyone know the square root of 144?
12.
12, good. You guys are locked in today. So yep, now we've solved for x. X equals 12, so we can write that at the top. And once again, the easiest way to do it is just to write all of these ratios or all of these variables as positive numbers. And then after you plug them in to the trig ratios, then you make the ones that need to be negative, negative. So from there, I'm going to give you guys about 2 or 3 minutes to solve for the remaining 5 trig functions, and then we'll go over them together. And if you need a reminder, we gave you the handouts on Friday, and they're also on the board behind me. Yep, so then tells us all are going to be positive. Smart, sine, trig, tangent, and then class, cosine. And then the only other thing to remember off of that is when one's positive, its sister function is positive too.
It's on the handout. Oh my god. I thought you were gonna stand up and then you were just like.
All right, so wrap up your thinking. It looks like most people are. So, not worrying about the signs. Do you guys agree with my 5 answers? That's a 13. That's a sloppy 13. There we go.
We're not including the negative.
We will. We're just going to go through that together. So, do you guys agree with my ratios?
Yeah.
Good, right? We're just plugging it in. I started with cosecant because it's the sister for sine. Just flipped it, and then from there, cosine is x over r. There, and then, yeah. So then we're in the third quadrant, right? So which ones did we say are positive? Yep, so tangent or cotangent are the only ones we don't have to fix. They're already right. And all the other ones we have to go back and make them negative. So it's going to be negative 13 over 5, negative 12 over 13, negative 13 over 12. And then we're set. Are there any questions for this example? Are you guys good?
Is it only the numerator that's positive on the one that, like I thought, okay, so does it matter if you put the negative on 13 or 5? Like for like
No,
cosecant?
doesn't matter. You need one negative, right?
Okay.
Yeah.
So if you leave the negative in the whole time from the beginning, like if y equals -5, you would get them wrong.
Well, this is where you have to be careful, right? Because we're in the third quadrant. So we found a positive x, right? But if you're doing it that way, x needs to be negative too. Because in the third quadrant,
No cancel.
yep. So that's why they give us the third quadrant, because they gave us r and y. And so technically, the square root of 144 is positive or negative 12. And the third quadrant tells us that we need to use negative 12. But then if you just from the beginning use all positive here, then you can just go back at the end and make the ones negative that you know need to be negative. Good? Cool. So now moving on, more for you guys to copy. I know it's example 2, that's all right. Copy down this question real quick and then we'll get into it. So as you finish writing down this question, I want you to look at the signs of sine and cosine, right? If it's positive or negative, and try to use that information to think about which quadrant we have to be in. Alrighty, show me on your fingers what quadrant we have to be in with a positive sign and a positive cosine. Good, I'm seeing all ones, great. Exactly right. Positive sign, positive cosine, that only happens in quadrant 1. And then off of that, looking at this question, right, there's 2 pieces of information it gives us. It gives us the ratio for sine and the ratio for cosine. Using what we know about these 2 ratios, we have been given x, y, and r. So from there, we really just have to plug in, or substitute in, and then rationalize the remaining 4 trig functions. Because we know y equals root 5, x equals 2 root 5, and then r is going to just equal 5. So from there, I'm going to give you guys a couple minutes, try to figure out the next 4 remaining trig functions.
Is there anybody else that was absent Friday? Okay. Anybody else absent Friday?
What?
You just multiply the root 5 for secant.
Yeah, we'll go over it together. All right, so I know all you got, everyone's not finished, but we're going to go through them together. So I wrote down cosecant and secant because I figured let's keep it easy and start with the sister functions. So we know the sister functions are just the reciprocal. And can someone remind me what quadrant we're in? 1. So what's going to be positive? Yep. A smart trig class, all 6 are going to be positive. So we don't have to worry about going back and making a negative. So looking at cosecant of theta, first thing we do is we flip. So we make it 5 over root 5. And then from there we have to rationalize, so we multiply top and bottom by root 5. And that's going to give us 5 root 5 over 5. Do you guys agree with me to there? Yep, those 5s are going to cancel out. That's going to leave us with the answer of just, oh, that was supposed to be in red. That's going to leave us with the answer of just root 5. Give me a thumbs up if you're able to get cosecant. Good. So then for secant, it's a very, very similar process. We just flip cosine because they're sister functions. So then we get 5 over 2 root 5. We multiply the top and bottom by root 5. And that's going to give us 5 root 5 over 2 times 5. You could have combined this 2 times 5, right, and just made it 10. But since there's a 5 in that numerator, I'm just going to leave it as 2 times 5. So then I can cancel out the 2 5s. And then I'm just left with root 5 over 2. That one was a little bit tougher to simplify, but give me a thumbs up if you were able to get that one. Yeah, question?
Would it still be like correct if we left it as 5 root 5 over 10? Or like if we did this on the quiz, 5 root 5 over 10, would that be fine?
So it's not simplified, so I would take off half a point.
Okay.
You always wanna reduce fractions.
Miss Bryant, do they have to worry about reducing inside a radical if need be, or they can just leave the radicals?
Oh, you mean like if the radical could be simplified?
Mhm.
Yeah, and pre-calc they should do that too.
Okay, cool. So just keep that in the back of your brains. So now we have 2 left, right? We have tangent and cotangent. And these are pretty simple for this problem. So I drew my funky T again. So tangent of theta is just, what's the ratio for that? Y over x, perfect. So y here is root 5. X is 2 root 5. Easy as can be, the root 5s cancel out, and we're just left with 1/2. And then cotangent, you kind of could have done this the shortcut way, and then just flipped 1/2 to make it 2. But the long way, right, will just be x over y, so 2 root 5 over root 5. Once again, the root 5s cancel, and we're just left with 2. Give me a thumbs up if you were able to get all 4 of those before we went over them. Good. Do we have any questions for anyone who was unable to get all 4? Anything that's still a little bit unclear? Or were you able to see where the mistake happened? Good. So now you guys can take out your quiz reviews, right? Take out the quiz reviews, and then who still needs to do the unit circle? It's still recording. I wasn't sure.
Oh, okay.